Good morning, everyone. Thank you for the opportunity. Today, I want to present our paper with the title is The Prospect and Challenges of Biopolymers for Enhanced Oil Recovery. But first of all, let me introduce myself. My name is Maudy Pratiwi from Universitas 11 Maret. Okay, this is the outline of this presentation. Consists of introduction, enhanced oil recovery, recently used biopolymers, mechanism of polymer flooding, and the last is conclusion. Petroleum production is projected to decline at a rate 3% per year. Oil production is not enough to meet the refineries' demand at 2050, so crude oil imports will be required to reach 146 million ton oil equivalent at 2050. There are some optimization strategies for drilling development wells to increase oil production. One of them is improve enhanced oil recovery for old fields. There are some methods to improve enhanced oil recovery. One of the enhanced oil recovery methods is chemical injection. Chemical injection show that have more advantages than other methods. The most important substance in this method is polymers. So recently used biopolymers that have potential to enhance oil recovery activities and mechanism of polymer flooding will be discussed. There are three primary stages of production in conventional oil fields. Oil from the reservoir naturally flows into the well in the early stages, but as the extraction of oil progresses, the pressure in the reservoir decreases and the flow of oil into the well decreases. As a result, secondary recovery is used to improve oil production. The most commonly injected fluid is water. The flow of primary and secondary recovery methods still leaves around 60 and 70% of oil contained in reservoir. As a result, additional recovery is required to extract the residual oil in the reservoir. Tertiary recovery, also known as enhanced oil recovery, is a method of extracting oil by energy from outside the reservoir. There are several main types of enhanced oil recovery methods, including gas injection, chemical injection, and thermal injection. There are advantages and challenges of each method. Now, chemical injection is starting to develop in the presence of large-scale projects ranging to laboratory work to field trials. Commonly used chemicals consist of alkali, surfactants, and polymers. Chemical injection may be performed by using combination of alkali polymers, surfactant polymers, or alkali surfactant polymers. Each chemical have a different function, and the most important substance in this method is polymers. Polymer flooding can increase crude oil recovery by 5 until 30% of original oil in place, and further improve the oil recovery by 3% after water flooding is exhausted. The overall cost of polymer flooding is lower than water flooding. Commonly used polymer in the enhanced oil recovery method is hydrolyzed polyacrylamide. Has several advantages, including its large availability, low manufacturing costs, and flexible features. But hydrolyzed polyacrylamide is very sensitive to reservoir conditions and have negative impacts on the environment due to toxicity and carcinogenicity of residual monomers of these polymers. So, from these problems, biopolymers become an interesting solution for the development of enhanced oil recovery method. Biopolymers are cheap, easy to get, and have environmentally friendly, and also have superior chemical stability. Recently used biopolymers attention to xanthan gum, cellulose, guar gum, and lignin. Xanthan gum is produced by Xanthomonas campestris microbes on the carbohydrate media substrate. Xanthan gum have mechanical shear, high salinity, and temperature resistance. But xanthan gum have challenges. There is bacterial degradation. So, to improve its properties under condition of high temperature and high salinity in presence of oil phase, there are some of modification of xanthan gum, and the result of the formulation. The modification formulation show that have lower interfacial tension in addition to high viscosity compared to the using of only xanthan gum. Okay, the second is cellulose. Cellulose have temperature and shear resistance, but cellulose is have a challenges. There is a nature of degradation, and there are modification of cellulose. There are the synthesis of nanocellulose by grafting cellulose to synthetic polymers. And the result of cellulose modification have higher salinity and temperature resistance than only cellulose. So it is potential to be applicable for polymer flooding. Okay, the next is guar-gum. Guar-gum is biopolymer derived from the two annual endosperm leguminous plants, Cyanopsis terragonalopus and Cyanopsis soraloides. Guar-gum are compatibility of various pH value and salinity, but guar-gum are poor thermal stability, potential risks of porous media plugging and biodegradation. So, guar-gum need modification to improve its rheological properties and chemical sludge stability for polymer flooding application. Modification guar-gum mixed with silica nanoparticles improve the effectiveness of guar-gum by restoring 44% of the original oil and in place. Okay, the last is lignin. The rheological characteristics of lignin are changed by concentration according to rheological experiments. There are several studies of lignin modification to improve its rheological properties. Lignin modification show that have lower yield stresses, lower reaction time, and lower viscosities than only lignin solution, according to the dynamic frequency sweep measurements from -7 degrees Celsius to 56 degrees Celsius. Mechanism of polymer flooding. When the polymer is injected into the water, it affects the rheological properties of the water. Polymer flooding is used to increase stroke efficiency by increasing the mobility of injected fluids. Pinching phenomena will occur when only injecting water into the heterogeneous reservoir, and the ejected fluids flow considerably easier than oil through the permeable medium due to its high permeability layer. In the figure 2 show a comparison of pinching phenomena caused by water flooding and polymer flooding. And adding polymers to the reservoir increases the viscosity of the water and decreases the relative permeability of the water, and increasing the oil gain owing to higher fractional flow. At the end of this process, injected only water into the reservoir make the large reservoir area are not contacted by water. Okay, the last is conclusion. Polymer flooding is a low-cost chemical enhanced oil recovery method with a high rate of success. This method has several advantages, including improving oil recovery by minimizing residual oil saturation, decreasing water output from oil well, and requiring less water compared with water flooding. Biopolymers have big potential for polymer flooding have shown some advantages such as eco-friendly materials, shear salinity and temperature resistance, and long-term stability. With the challenges of biopolymer is biodegradation. Temperature, salinity, and biological activity degrade the information contained in polymer molecules, resulting in viscosity loss and polymer adsorption. There are some studies to improve biopolymer properties, such as modification biopolymers with nanoparticles or modification biopolymers by grafting with synthetic polymers. Okay, that's all that I can provide to you today. Thank you for your attention. And the author would like to thank the Indonesian Directorate General of Higher Education for funding this research under Penelitian Fundamental 2021 PNBP Universitas 11 Maret.